Hello, everybody, and good afternoon. Today, we want to talk about the latest news about ntop and what we have done in the past months. In particular, in mid-August, we have done a new software release. And today, we would like to discuss what we have changed into the tools and what are the things that we are planning to do in the near future. So the webinar outline will be, first of all, some news from ntop. I will describe, what we have done, what are our plans inside the company. Second, I will give you a quick update about nDPI and nProbe, and then I will pass this to my colleagues that will talk about ntopng, ntopng, and Cento. And then at the end, I want to have a quick question and answer session. So in case somebody has some feedback or is willing to ask us questions. At any time, you can type your questions in the chat. So in case you want us to answer immediately. Okay, first thing that is not so relevant for the software, but we have spent a little bit of time here working the ntop site. So we have changed a little bit the lookup. It's not very different from the one before, but it was a little bit old style. This one is a little bit better, a bit more modern. Probably we'll do some improvements in the future, but at least it looks more professional. And both in the shop and in the various pages that you can use for checking the status of your tickets and generating licenses, we have changed the layout, and the layout is more similar to across all the various ntop tools, and is similar to the one that I show here in this website. Everything else is the same, no price changes, nothing more than that. As you can see at the top of your screen, there is now drop-down menu so that you can select the specific products. So in case you want to see only products, let's say for OpenSense or for Raspberry, it's very easy, so you don't have to go through the long list of tools. The second thing that we have introduced with version 6.2 are changes in licenses. So to make this long story short, we are spending a lot of time with support with some users that are somehow, let's say, misusing the tools that are, probably for laziness or probably for lack of us communicating the right information, are somehow putting a lot of effort on specific, instances that have performance issues. So they have sometimes packet drops, flow drops, and things like that. And at the same time, we would like, in addition to reducing support time, to make pricing fair. So we would like to see if it's possible to maintain, as we have done until now, prices as low as possible. But at the same time, ask people with huge enterprises, telecom operators, and so on, to pay more so that we can compensate, them with additional resources. For this reason, we have introduced some restrictions, okay, that some of them were already present. Actually, most of them were already present in previous versions, but were not enforced. So the story is this. Today, I'm talking about nProbe and ntopng and no other changes to the other tools. In nProbe, so we have some restrictions based on the number of collection devices. Based on the version, nProbe Pro can have, let's say, 4 collection devices. So from 4 routers or switches that are sending flows to it, Enterprise has 8, 16, and 128. So it means that based on the number of devices that are sending data to it, nProbe is able to handle them or not. So this is a restriction both for price fairness, and also because there are many devices that are, especially today, that have many template definitions. So in essence, the more devices you put on a single nProbe instance, the more work we have to do whenever a flow is received. I'm talking about FFX and NetFlow. So it's very important for us to tell people that it is very important not to put a complete company, okay, on a single nProbe. First of all, because nProbe can fail, can be unreachable, and so on. So it makes sense to load balance the traffic across multiple instances. But also at the same time, it is important to understand that if you have limitations per instance, okay, doesn't mean that that's all, because you can start multiple instances of nProbe on the same box, okay, and share the load. So let's make an example. Suppose that you have an nProbe Enterprise S that can collect from 8 devices. So if you have 12 devices or 14 devices, you don't have to buy necessarily the Enterprise M, okay, but you can start 2 Enterprise S instances receiving flows that are sending them to ntopng. And this makes sense from 2 points of view. First of all, because you will not balance the load. So it means that the system will be more efficient and will not put pressure on a single instance. And second, you don't have to upgrade your license. So this is the idea behind this restriction. The same thing we have done with ntopng. As I've said, most of those limitations were already present. Actually, some of them are being raised. So for instance, the number of exporters on the enterprise L has been increased to 512. But in ntopng, we have a different problem because every nProbe that is collecting flows from many devices has to talk with the ntopng. So it has to report continuously at the moment every 3 seconds statistics about what is happening because we need to understand, flow drops, where are those issues. And having a large number of devices sending data to us puts pressure on the instance. So this means that we have the same problem. So in essence, instead of having a single instance or a single interface where everything is sent, we prefer you to load balance the traffic across multiple interfaces or multiple ntopng instances running on the same box so that you can maximize the usage of cores. This because on modern systems, you have many cores, especially on AMD systems. You have tens of cores. But at the end of the story, if you have only one interface receiving flows or receiving packets, you will end up using very few of them. So it's very important to understand those limitations from our side that are helping us to reduce, headache during support and you being disappointed when you see drops simply because you have collapsed everything into one interface, and also to make pricings a little bit more fair. For those who are not happy with those limitations, so that need to have more, let's say, resources, so we have an XL Plus, let's say, version available on demand that we want to use on a case-by-case basis because at the end of we would like you to survive with those limits, at least for the moment, because this means that you can load balance the traffic across the instances. Now, also talking about the licenses, a popular topic today is support of containers and Kubernetes in a better way as today. In particular, if you have containers or pods that are moving across multiple machines, the way licenses are working in ntop is very complicated because they were created many years ago when there were no containers or no very dynamic environments. So at the most, we had VMs. So with the concept of system ID, in essence, you are bound to a physical machine. And if you have a container, you can map the container in a way so that the container can see the physical machine for license checking, and that's it. But if you have very dynamic environments as Kubernetes, this doesn't work. Another problem is that in companies, sometimes people would like to have all the licenses on a single place, okay, and have those instances talk with a sort of license manager that says yes or no, okay, and whenever there is a new license to update, you update only the license manager and that's it, without having to put an individual license on each machine. And this is particularly complicated if you have many deployments or many virtual machines or containers that continuously going up and down. For this reason, some of you have asked us to implement a license manager. So a license manager, it's an application we are developing. We plan to release the first version by the end of this month that you will install somewhere on your system, on a container, on a VM, on a physical box, doesn't really matter. It's just a process. And when you have instances of ntopng or nProbe that need to be activated, instead of checking the license locally, they will go to speak with the license manager that has to run on your network, okay? And we'll say, I need a license, give me the license. So this means that we also we change the way licenses are working because at the moment, the license is per system ID. But in this case, the license manager will have one license for many instances because you can have, for instance, one ntopng license that can be used or shared across, let's say, 10 instances that you have in your organization. So we've changed a little bit the way licenses are working to simplify the way they are deployed. And also to make sure that for companies that are very data sensitive, they still can keep running the software locally. Okay. The only limitation we see is that the host that is running the license manager has to speak with the ntop cloud to report the data, so that you can see from the cloud display, the cloud web interface, what is happening at your license manager. You know how many instances are up and down and sort of usage data. And as I've said, this is designed in particular for handling Kubernetes in a better way. Another thing that we have changed that is probably, again, not relevant for the software, but for the users, is the way you renew a maintenance. I acknowledge that the way it was implemented until now was a little bit complicated. In essence, when you want to renew maintenance, you have to go to the shop, you have to enter your data again, your address, your company name, blah, blah, blah. And then at the end of the story, inside the discount code box, you will put the previous order ID in order to get a discount. And this is a little bit complicated for many of you, and I acknowledge you were right. So for this reason, we have created a new system for renewal, very quick renewal system. So in essence, there is a new renewal URL, shop.ntop.com/renew, where you put your order ID that you want to renew, okay, and your email, okay, the email that was bound with the original order ID. As soon as you click the blue button, you will see on the screen the cost of renewing the maintenance, okay, for all the products inside the order. And you will receive an email saying that if you like the offer, okay, you can click on email and immediately go to PayPal, pay, and that's it, end of the story, okay, without having to re-enter your data, re-enter license information, platform information, anything like that. If there are versions that no longer exist, they will be migrated automatically. If you have, let's say, an update, then the update will be handled automatically. Everything is very simple with one click. And in the next weeks, we'll introduce this inside ntopng. So whenever you see, the renewal maintenance box, click on it. You can immediately go here and renew it with one click. That's all for licenses. Now we want to talk about a different topic. First of all, professional training. Some users have asked us to do a new session of the training, okay, that we deliver through Teams. So the fall edition of the training will be in October, from October 15 to October 31st. For those that don't know how it works, so in essence, we do 90-minute session twice a week, okay, for 3 weeks. And they will cover basically the main topics of nTop, starting from the introduction to everything for those that are not familiar with the tools, how to install the tools, how to license them. And then we have various sessions on specific arguments such as network intelligence, flow collection, historical data, active monitoring, and SNMP. Because SNMP, as you know, we have extended it quite a bit in the past releases, so it's becoming an important topic for many of you. And there is a URL that you can find here at the bottom of the slide, but you can also go to the nTop website and you select it as usual and go directly to the page. Now let's talk about the nTop conference. We plan to have a conference either this year or next year. And in particular, we have received requests from our community, in particular in German-speaking countries, asking to have some sort of event, in a local place. The initial thought we had was to make it in Munich, that is south of Germany, so that other people from Austria and Switzerland can go there. But then at the end of the story, we thought that probably we needed, a different idea, because Munich is a good place, but there are also other options that we considered, and consider that nTop as headquarters also in Switzerland. We thought that Switzerland was a good option. So therefore, today I'm here to announce that the conference will take place next year, May 7th and 8th in Zurich. Zurich is very close to the German border, to the Austrian border, so it should be very easy for those that are willing to travel to come and attend the conference. As usual, it will be divided in 2 days. The first day will be training. Okay, so we want to make sure that everybody is up to date with our tools. Probably we'll change the format of the training this time with respect to the past, because we would like to understand in advance people that are willing to attend it, what type of training they have in mind. So for instance, how much they are experienced, so that for unexperienced people, we can give an introduction. For those that are experienced, we can give something more advanced, okay? Otherwise they will be annoyed by things that they already know. And also, we have made some polls, but we'll do this soon again, about the content. Okay, and we would like to divide it in classes in a more interactive environment, because through Teams we can deliver training, but necessarily with Teams you have to somehow to present and see what people are doing in a limited way. Instead, in a physical location, you can also do some exercise, have a more workshop-like, let's say, interaction. So it's very important for us. We believe that this is it's a good thing to do, and we believe on that. And in the second day, instead, we'll be talking about ntop, in general. We expect not to have just ntop people on the stage, but we would like to have also other people that are using our tools in very different environments, probably that we don't even know, to come and speak. For those that will not be willing to attend it in person, okay, we also would like to make available for speakers the ability of giving a speech even though they are not in person. And then we would like to record the event as we did in the past and make it available on YouTube and on our channels. By next week, we'll be announcing the website. So we want to start collecting calls for presentations, because I've said we would like people to come and speak, okay, even though they will not be there in person, okay, they can also work and speak from remote. Of course, we have to take into account time zones, so probably in the morning we'll be speaking, from Europe, okay, in the afternoon, if there are some people from remote, can speak in the afternoon, and if they are from US or from Asia, in the morning. So we will be very happy if you can apply for that. We want to give a presentation, and because we believe that ntop is something we have created but belongs to all of you. So this is the good time for meeting people in person. This is all. So this is all I wanted to say. Okay, let's now have some quick notes about nDPI and nProbe. Okay, with nDPI 4.10. We have introduced many new protocols. We have more than 420 protocols, and we have introduced the most recent protocols, such as Google Call, Mastodon, Viber, Voice over IP, or ClickHouse. Some of them are not really protocol from the RFC standpoint, but it means they are application protocol used by many people every day. So that having an idea what people are doing is becoming important, in particular if you want to enforce traffic on a LAN. Those that are using our tools know that nDPI is able to deliver also something we call a flow risk. So it means the ability of identifying unexpected situations in network traffic, such as, for instance, you have a communication stream that you don't know the nature, but that is fully encrypted. Okay, so it can become interesting, in particular for data filtration. Or, for instance, information about TLS that is hidden, is encrypted. It is important to understand also how the TLS communication is made. And for instance, we have added a new risk about mismatch between the TLS configuration. So let's say people have a bad experience when connect to the website, or misconfiguration means that maybe something is outdated and needs to be updated. And of course, we have added some extra information about the malware host content. In this version, we have reduced the memory footprint a little bit more, and in particular, we have improved the performance. Because many companies are using an nDPI beside us, we also have extended the test coverage, many thanks to Ivan and our contributors, and the fuzzy testing. And this is becoming very important for having a robust tool. But one of the first innovations that we have introduced with this release that will be extended in the coming release is what we call first packet classification. If you go to the ntop blog, you will see an article we have written today. So in essence, the story is very simple. With the deep packet inspection, okay, you can detect a protocol looking at the packet payload. So you need a little bit of traffic to understand what type of application protocol is behind a certain communication. But if you have a UDP-based protocol, okay, some UDP-based protocols, so for instance, such as SNMP or QUIC, it's possible to detect the application protocol from one packet, okay? Because you see inside the packet, for instance, the QUIC negotiation that is on the first packet. But unfortunately, most of the protocols don't support that. And we would like to have first packet classification more or less, spread across all the possible protocols, because first packet classification means that as soon as we see one packet from a flow, we understand what is the application protocol. And this is very important, in particular for cybersecurity or for enforcing specific protocols. So we have introduced this tool that at the moment is this method, sorry, that at the moment is available in three fashions that will be extended later on. The first way is through DPI. Again, this can happen only with UDP traffic because with UDP protocols, you can detect the protocol at the first packet and that's it. The second option is through IP addresses. So inside nDPI, we have a list, a big list of IP addresses that are delivered reliably by companies. So for instance, from Meta, for Facebook, and Microsoft for Teams and other tools. So Microsoft, for instance, guarantees that whenever we see traffic from a specific IP, okay, this is bound to a specific protocol. So for instance, for Microsoft Teams, we can analyze Teams, doing the packet inspection, but at the same time, we know in advance that this is Teams because it's necessary for network administrator to configure that IP inside the router to make sure that it's open from the first packet. And this is easy. So the first two techniques are very simple. The third technique is something we call DNS. So the story is very simple. Whenever we see a DNS request, we look at the domain name that has been resolved. So in this example, I put is 12.whatsapp.net. And because whatsapp.net, it's a domain name that nDPI understands. So we have a list of mappings between the domain name and the protocol. So we store into the cache the fact that the IP address 15.197.206.217 that has been bound to whatsapp.net means WhatsApp. So whenever we see traffic after the DNS request that is going towards this IP, we don't have to decode the traffic. We simply have to know in advance that this is WhatsApp. So in case you have a policy that say block me WhatsApp or give a preference to WhatsApp traffic, you know that in advance, okay? And of course, we'll continue with the standard DPI. So in case we want to extract, TLS information as usual. But this is a quick check that allows us to improve quite a bit the performance of the tool because we have to reduce the workload. At the same time, we are going towards one packet classification. Again, this is just a work in progress at the moment. These three techniques have been implemented, but we plan to extend more techniques in the future to improve that further. Let's now move quickly to nProbe 10.6. So the main changes in this release have been for monitoring telco traffic, particularly mobile operators. We have in particular GTP version 1 and version 2 that are used by 3, 4G, and 5G. And we have revamped the IMSI to GTPU correlation. That means, in essence, that we can correlate a telephone number with a certain network traffic. And this is, again, it's a very vertical feature. The other features are more mainstream. So we have reworked Kafka, that is becoming an important protocol for many of you, in addition to ZeroMQ that is used for ntopng. Inside Kafka, we made a more flexible export. We know that Kafka has various options, so we made it very, very flexible so that we can deliver this data in a more reliable way. In addition, so we have extended the monitoring of protocols such as Teams, Zoom, and Mix, so the collaboration tools, for understanding the quality. Unfortunately, those tools are using standard protocols such as RTP, but they're misusing them. So they have added a very, let's say, private extensions, and they're continuously jeopardizing the protocols. So this means that in this release, we have updated our tools to make sure that they are detected. We can give you information not only about the stream, so if it's media, screen sharing, or audio, but also about the quality of the stream. And finally, we have made many changes inside nProbe to deliver to ntopng the information about nProbe itself. So the number of interfaces I just mentioned before, the drops, and so on. So in case you have big deployments where you have many instances of nProbe sending data to ntopng, you know immediately what are the interfaces that are dropping traffic, if there is too much traffic on a certain host, and so on. So this allows you to load balance the traffic a little bit better, okay, and to understand if there is a performance hog, how to reconfigure your instances, and to make sure that everything is in good shape. So this is my last slide. I let my colleague speak, and again, at the end, we'll do Q&A sessions.
Hello, everyone. Let me share the screen. Okay, you should be able to see the slides, right?
Yes.
Okay, great. So now let's talk about ntopng. About ntopng, we have many new features and announcements to do. If you remember, in the last two stable version of ntopng, we were oriented towards a new UI. We introduced the Vue.js plugins framework. We made a new dashboard report page. We did a lot of changes regarding user interface. Now, in the ntopng 6.2, the last stable version, instead we have many new announcements. First of all, regarding performances and memory usage. We did quite a lot of enhancement regarding those aspects. Announcement regarding SMP and cybersecurity features. Let's start before jumping to the real changes to the ntop cloud. Like Luca already talked about before, with the ntop cloud, now we are able to add our instances of ntopng, like you can see on this image, on the screenshot, and our stable products, so ntopng and probes and so on, and be able to monitor if the instances are okay or have problems, if they have a license okay or not. So now let's jump to the changes regarding memory usage and performances. In the last version of ntopng, we were able to lower the memory usage of the ntopng tool by more than 60%, as you can see from the first screenshot, the first image, this one. We lowered the memory usage from 572 megabit to 190 megabit, even less than that. This for a small deployment. Instead, for a larger deployment with a lot of traffic, interfaces, and so on, we are able to lower the memory usage by half, as you can see, from 3.73 gigabit to 1.8 gigabit. And not only that, but we were even able to enhance the performances regarding, however, the SMP polling and all the features regarding SMP. Because we improved the coroutines regarding fat MIBs, so the MIBs with a lot of information that take quite a lot of time to poll all the information. And thanks to that, we are able now to monitor even more devices having less work to do. Other than that, instead, other than the performances side, we even introduced the possibility to pull SMP information from flow exporters, because many times if we have a flow exporter exporting flows towards ntopng, we are interested in those routers or switcher. We are interested to know if they are okay, if the traffic done is okay, or if they are congested. And for that reason, we decided to add these kinds of polling. So now, if you jump to the flow exporters, in case of exporters where you have SMP enabled, you are able to see so a per minute time series instead of the old 5 minutes time series. So just to give you an example, here we have an ntopng with different, quite a lot of exporters and probes configured. We can simply jump to the flow exporter page, the new page that Luca showed you before. And from here, if we click on the right probe, we can see the exporter. So let's see the time series. These are the classic code time series. And here you can find the SMP instead per minute. If you are interested instead on the interfaces, so in the exact information about the interfaces, so the time series regarding interfaces, again, click on the exporter, and you are going to jump on the page with all the interfaces that are currently exporting data. And from here, again, from the chart icon, you are able to jump to the time series page. And as you can see, we have a per minute time series difference. In this way, we are able to understand if our exporters are working correctly, or if they are congested, or if they have any kind of problem. So I talked a couple of minutes ago about congestion because we added again regarding SMP the possibility to understand if some SMP device is congested or not. So first of all, let's jump to the SMP page, like usual, monitoring SMP. And if you enabled the time series, the SMP time series, see a usage tab here on the menu. We can click here. Let me zoom in. And you jump to this page, top congested interfaces, with all the interfaces and devices you have configured regarding SMP. In this page, you are able to understand the congestion rate. So if some device is congested or not, the average usage of that interface, and so on. So let's jump to an example to have a better idea of this feature. Um, I put the last day, so we can see the last day time series. And as you can see, we have a couple of interfaces with quite a lot of traffic, 95%. In fact, as you can see, it is the first one. It should be this one. This one is one of the 4 congested interfaces. Regarding congestion, what do I mean with congestion? Simply put, as you can see in the description here, we mark an interface, an SMP interface, congested if more than 65% of the link, so if it is a 1 gigabit link, if more than 750 megabit per second are done, then that link is going to be labeled as congested. And as you can see, in fact, here we have 4 devices congested. And if we click on one of these, we can see the time when the link was congested. So as you can see, we have an output link usage of 95%. That's quite a lot. Now, obviously, the amount of traffic that a link is able to support is an information pulled by SMP. However, obviously, you are even able to configure those links because in many cases, sometimes it is better to have these links configured manually. And in this way, you can check the status of your interfaces, switches, routers, and so on. So still regarding SMP, we have some new announcements. We added the support to the Cisco QoS MIB. So if you have some devices with the Cisco QoS MIB enabled, you can enable the polling of those information from those devices. For instance, in my ntopng instance here, I have one device with those MIBs, this one. And as you can see, we have the QoS page. If you want to enable the QoS polling, you can enable from the configuration page. Just turn on this option and save the settings. And from now on, this device is going to export, ntopng is going to ask for the QoS MIBs too. Now, note that the QoS MIBs are quite important in many cases, MIBs, so they export a lot of information and they could take some time. Other than that, regarding SMP, we added the support to the collection of SMP trap. So the SMP traps are, simply put, information that the SMP provides, and we can visualize those information still in the well-known alerts page on the SMP tab. Now, regarding instead alerts, we decided to add the support, let's say, in ntopng to the MITRE attack, because ntopng has many cybersecurity alerts. And what is MITRE attack? As you can see from the definition of MITRE attack, it is a globally accessible knowledge base regarding cybersecurity alerts. Okay, so cybersecurity attacks, tactics, techniques, and so on and so on. So we decided to put those information into ntopng because many times users were not entirely sure on the alerts meaning of ntopng. In this way, we did the mapping one by one on all the cybersecurity related alerts on ntopng with the MITRE attack. And this is the result. So now in ntopng, in the alert um, drill down, let's say, you can see, yeah, our description. So from the ntopng, or in this case, it is a risk, so from nDPI description with the kind of MITRE attack it is. So for instance, to long TLS certificate validity, it is a well-known attack, known on MITRE attack as defense evasion. This is the kinds of technique and sub-technique used, uh, exploited to attack a system. So in this way, we hope that the users are able to understand better our alerts and meaning behind those alerts. And not only that, because now we are trying to move ntopng not just from a tool that is sending alerts, but even we are trying to extend ntopng to a software that provides a remediation, we like to call remediation, regarding that specific um, problem issue in the network. So if for instance we have, like before, a TLS certificate validity too long, if you click on this plus on this medbag here, you are going to jump to our documentation where you can see, first of all, the description of the alert, so the specific description, then the possible attacks used to exploit a weak point in the network, and the remediation, so how to fix possibly that issue. So just to give you a live example, let's jump to the Alerts Explorer page like usual, and let's jump to the flow. Um, okay, let's put all the alerts. Okay, we have, for instance, Elephant Flow. Let's see if we have some more juicy alerts. Unexpected NTP server. Let's see if we have something more. No, okay, unexpected NTP. If we click on info, so like usual, we drill down in the alert information. Here you can see, like I said before, the description of the alert, the standard score. Sorry. So from our point of view, how it is important this alert, the description, and here you can see the medbag icon, where if you click, you are going to jump to a description on the potential causes of this issue and the recommended action. So we are trying to move to a more interactive software, let's say, not just to give you alerts, but even to give you answers to those alerts. And like I told you before, here you can see instead the MITRE attack information. So which kind of alert this is this? And you can see, for example, many times the unexpected NTP server found it is used as a network denial of services reflection amplification with all kinds of information you can imagine about. Before jumping, however, to the new integration, I want to point out that other than all these features, we are still moving ntopng to a full separated client and server software, meaning that we are trying to move ntopng to the ntopng web interface to a full Vue.js software. And for this reason, we developed quite a lot of new pages, like, for instance, the Flowrise page. Probably you have already noticed that we changed the user interface, not just to have a more beautiful interface, I think, but even more useful. For instance, what we want to achieve is finding an issue as fast as possible. For this reason, we added the possibility, for instance, here in this page, to insta-click and insta-filter all the information. And if you want, you can reset, filter out by flow exporters, hosts, and find all the problems, because many of the time our software is used to find problems that there are on the network. We have, for instance, added um, the flow exporter page, like Luca have shown you before, and me too. Here you can see, for instance, all the nProbes and the exporters connected to ntopng, the amount of exported flows and failed exports. So to understand if you have some issue with exporting flows, if nProbe drops some flows, and so on. The same goes for the exporters. So to be able to see all the exporters you have or interfaces, and see, as you can see here, for instance, the limits that Luca told you about before. So as you can see, we have currently 3 exporters exporting data to ntopng. Lastly, like I was saying, we added even new integration. We added integration regarding alerts, so we are able now to export alerts to WeChat, a popularly used tool, the Hive, another well-known tool regarding this information, and lastly on syslog towards CheckMK. Instead, regarding time series, we are happy to announce that we support now InfluxDB version 2. Now, InfluxDB version 2 was released quite a few years ago. However, until now, we decided not to support that version because it has some problem, quite some problem, both regarding performances and the usability. So what we decided to do, because many of our customers are currently using Influx, we decided to partially add a version 2 support. So you can now export information time series towards InfluxDB version 2, however, not using the Flux thing and so on, but you have to configure a v1 bucket, and we still export those information to the version 2 with the v1 v1 API. Now, if you are interested in this feature, we even posted the blog post on how to configure all the things, all the influx and all the ntopng to achieve that. So it is pretty simple. It is not complicated at all. And now you can even export time series to InfluxDB version 2. Lastly, we added new translations thanks to Gabriele. We added three new languages, French, Korean, and Spanish. And we were able to implement those translation thanks even to the Google Translate library in Python. So we get our old languages and then translate to the new languages. So if you're interested in new languages, just let us know. With this tool, it is pretty easy to add new languages, even if they are not perfect, but they are pretty good. Now I leave the presentation to Alfredo, that will continue with ntopng.
Thank you, Matteo. Let me share my screen. Hello, everyone. This is Alfredo. Please confirm that you can see my screen. Hello, can you hear me? Yes, okay. Okay, so I want to show 2 more features that we introduced in the new ntopng stable. Then we move to Cento and ntopng. So in the previous ntopng stable versions, we introduced a new rendering engine for dashboards and reports. With the new with this stable release, we also introduced customizable reports. So we introduce an editor that you can use to create custom reports for your historical data. Those who are using the development version are probably already familiar with this, are probably already using this, but let me show you a quick demo about this. So if you go in ntopng and we jump to, sorry, my mouse, and we jump to the dashboard traffic report, here we have a report on historical data. So here we can see the top categories, applications, protocols, a lot of historical data. Here we have a selection of multiple reports. And what we can do here, we can create a new one, a custom one using the editor. So here we have an icon where we can click, specify the name of the report, like my template or my report. Save. And this is creating an empty template. Now we can click again on the editor and start adding widgets. For instance, I want the top applications, I want the interface traffic, I want, I don't know, the top categories, and you can also move the widgets across the report. You can also change a single widget. You can change the title, my top app. You can change the size. You can change what you see inside the data that you see in the widget. For instance, you can see the current data, which is matching the time interval that you specify in the report, or you can use offsets. So for instance, you want to compare the traffic today and yesterday, you can add a widget which is showing current traffic and another one which is showing one day before. And you can even filter, customize it, changing the parameters that are used to call the REST API to get the data. So as you can see here, we changed the name, we changed the size of the widget. So this is how you can create custom reports. Now, we also introduced a new built-in report, which is the security report. As Matteo said before, we are now able to classify alerts based on the MITRE ATT&CK classification. So we created also a security report, which is showing information like the top alerted hosts, but also statistics about the MITRE ATT&CK classification for alerts related to flows and alerts related to hosts. So here you can see what are the top MITRE attacks according to the MITRE attacks IDs, what is the top MITRE tactics, impact, command and control, for example, or the top MITRE techniques. Now this is, as I said, the security report. At the moment, we have just those statistics, but if we want to add more information, we already have a ticket open on GitHub asking for improving the security report. So we will put more information in this report. And we think this is really useful when checking the network from a security point of view. Another nice feature that we added recently in ntopng, both on the development and stable version, is the ability to replay historical flows. What does this mean? So this is the ability, in essence, to get the historical data that you have on ClickHouse. For instance, if you are analyzing traffic from the last week, get this data and replay into a live interface in ntopng in order to be able to use all the features that we have in ntopng to analyze live traffic, but for analyzing historical data. Let me show you a demo. So if you go under flows, historical flows, here you get all the traffic information for the selected time interval. So let me specify the last day. I want to analyze traffic matching a specific IP, for instance. So I'm filtering the historical data based on this specific IP address. Now I want to use the live features to analyze this traffic. So I can click on the replay button. This will process the records in database in a interface, in a live interface, which is the database interface. So as you can see here, we have a new interface, which is database, which is showing you, visualizing the traffic information that we had in ClickHouse. Here you can use all the menus that you have for the live, that you usually use for analyzing the real-time traffic. For instance, you can jump into analysis to aggregate the traffic based on several criteria. You can check the hosts, you can check the MAC addresses, and so on and so forth. So you can use all the menus, for instance, even the maps, for instance. As you can see here, we have this chart, which is showing information coming from the historical data, not from the live interfaces. One thing you have to pay attention to is this badge. So when you click on the replay button, depending on the time interval and the traffic that you have, this may take a while to process all the traffic. So while ntopng is processing the traffic, this badge is displayed, so loading. So you have to wait until this disappears in order to make sure that all the traffic in the time frame is ready to be analyzed and visualized. Okay, now let's move to Cento. So you probably already know that Cento is our 100 gigabit probe. So the probe that we use to analyze 100 gigabit and export traffic information like NetFlow or other formats like Kafka or others. We introduced many new features in Cento 2.0, which are the hardware flow table offload available with Napatech Smart NICs, the Apache Avro serialization format, custom flow templates, and the ability to steer traffic per application protocol when using Cento IDS. Now I will go through all of them. Let's start with the first one. So what we modern smart NICs, specifically Napatech adapters, include a new component in hardware, which is the flow manager, which is the ability to keep track of network communications in hardware. So the adapter has a flow table, in essence, a cache, where it stores information about all the network communications and is able to update the counters based on the packets and bytes seen for all the network communications. So we integrated PFRing. We added support for the flow manager in PFRing, and Cento is using, of course, PFRing for the packet capture. So in practice, Cento is now able to use this flow manager to accelerate the flow processing activity. But let's see a couple of examples. There are a couple of working modes that you can use in Cento, leveraging on the flow manager acceleration. The first one is the passive mode, and then we have the inline mode. But let's start with the passive mode. With the passive mode, I mean, this mode is what is usually used to analyze traffic in a passive way. So traffic coming from a spam port, a tap, a mirror, process the packets, extract flow information, and export net flow. So in this case, Cento is using the adapter as a cache for flows. So Cento is receiving the initial packets of network communication, creating the flow in memory, and creating also a new flow in the adapter cache. Then after Cento has done with the initial flow processing, that means as detected, for instance, the layer 7 protocol using nDPI, Cento offloads this flow. This means that from this point, the adapter will just update packets and bytes and other counters in the flow, and Cento doesn't have to process packets anymore for this specific flow. So this is how this flow table offload acceleration works. Coming jump into some numbers, I want to show you what is the performance boost that we get with this acceleration. In this case, we have a traffic generator which is generating almost 90 million packets per second. In this case, that's 60 gigabits per second because we had small packets. This was a limitation of the traffic generator, but this is usually much more than what we usually have at 100 gigabits per second. And we evaluated the CPU load at different numbers of concurrent flows, concurrent network communications. So at 10,000 network communication, 100,000, or 1 million. What you usually have in an average network at 100 gigabits is something in the middle between 10,000 and 100,000 flows. The 1 million flows is really a worst case, for instance, when you are under a DDoS attack. So if we look at the CPU load, in the average case, let's say that when running Cento with a standard adapter with no flood, the CPU load using 16 cores, the average CPU load per core is somewhere in the middle between 30 and 50% of the load. When using the hardware offload, this is really close to zero because most of the work is done in the adapter. Because what Cento has to do is just to allocate the flow and process the initial packets that can be 3, 5, maximum 10 packets of the flow until it detects the application protocol, and then offload this flow to the adapter. So all the subsequent packets don't require any lookup in the software flow table. And it is this leads to a much lower CPU load. And let's also take a look at the packet loss. So in the average case, even Cento using just a standard adapter without any offload is not losing any packet. But in the worst case, so when we have many flows, concurrent flows, and Cento has to allocate many flows in memory while doing lookups for the other flows which are already allocated for every single packet, then this is leading to some packet loss. With the hardware offload, we have still zero packet loss in this case. The other working mode is the inline mode. So in this mode, Cento is acting as a transparent bridge, forwarding traffic between two network interfaces, for instance, between a firewall and a core switch, in order to drop unwanted traffic at layer 7 or traffic for specific subnets, for instance. So it's acting like a layer 7 firewall, let's call it this way, a layer 7 policer. We can use the hardware offload also in this situation because the adapter keeps track of all the network communications and is able also to forward traffic between two interfaces. And is also supporting the flow markers. So as soon as Cento decides that a flow should be discarded, it pushes a flow verdict to the adapter. So it's marking the flow like discard this flow. And the adapter is taking care of discarding all the packets, future packets for that specific flow. Let's look at some performance numbers. They are very similar to the passive mode. As you can see, this was the passive mode and this was the inline mode. So here we can see that when running the software-only mode, so no hardware acceleration, the CPU load is even higher. Instead, when running the hardware offload, the CPU load is more or less the same. Here, the CPU load when using software-only is much higher because in this case, we also have to transmit the packets. So the CPU has to receive the packet, inspect it, and transmit with a packet copy. In this other case, most of the traffic is moved by the adapter. So zero copy, actually, it's not hitting at all the CPU. And similar scenario also for the packet loss. So with a few So let's say with average number of concurrent sessions, there is no packet loss even with the software only technology. With the hardware offload, we have zero packet loss even in the worst case. So what are the advantages of using the hardware offload besides the lower CPU load? The main advantage is that you're using less CPU cycles because you're doing less lookups for every single packet in software, but you're also using much less memory bandwidth and PCI bandwidth because the data is no longer moved to the CPU, but is processed directly into the adapter, especially when you have to bridge the traffic, because the traffic is copied by the adapter from one interface to the other without crossing any PCI bus or memory bus. And this allows us to process much more traffic on a system, especially when the bus or the memory is becoming the bottleneck. So we can process with this approach multiple 100 gigabit links on a single box. And this still let us combine the flexibility provided by the software and the ability, for instance, to run deep packet inspection, for instance, nDPI in software, while using the hardware for offloading as much as possible. Another new feature that we have in Cento 2.0 is the Apache Avro serialization. This is a serialization format which is encoding the data in binary format, a compact format, and it's commonly used by many big companies for serializing records, for instance, like NetFlow, and creating streaming to create pipelines for processing data in streams. And Cento is able to automatically generate the Avro schema starting from a template which is provided to Cento and generate this schema in JSON format. And the JSON schema is what you usually use when you have to build your applications based on Avro. You provide the schema and they usually automatically generate the encoding and decoding code. The Avro serialization in Cento is available when you export the data using Kafka. So we say that we can convert flow templates into an Avro schema. For this reason, we introduced in Cento also the new custom flow templates. So similar to nProbe, it is possible to specify in Cento a custom template specifying a list of information elements. For instance, in this example, we have -- template, source VLAN, source MAC, dest MAC, IP protocol version, IPv4 source address, dest address, etc., etc. So here you specify all the information that you want to export. And the template is supported when exporting the data using the Avro serialization format or also the JSON serialization format to Kafka. Let's say the last of the main features that we introduced in this Cento version is the ability to steer the traffic based on the layer 7 application protocol. We're using Cento IDS. So in IDS mode, what is the IDS mode? The IDS mode is the ability to use Cento to process the traffic and at the same time load balance these traffic packets to multiple other applications that can be, for instance, multiple instances of an IDS like Snort or Suricata, for instance. Now, in some case, you have we have customers that need to process specific application, so traffic matching specific application protocols with specific decoders or traffic analyzers. For instance, let's assume that you have your traffic and you want to load balance this traffic to multiple IDS systems, but you want to process the DNS using a specific application, which is a DNS analyzer. What you want to do here is to load balance the traffic in round robin to the first 3 queues or network interfaces, but send the DNS to a specific queue. So for this reason, we introduced the ability to steer the traffic based on the layer 7 protocol. In order to do this, you use Cento IDS with an ingress interface, and then you have this option, which is balanced egress queues, where you specify if you want to send packets to multiple software queues or network interfaces if you are running IDS on a separate machine, and then specify the egress configuration, which is a set of rules that describe how you want to balance this traffic. And here you can specify, for instance, that you want to forward everything, load balance everything, discard encrypted traffic like SSL, but send the DNS to the interface ETH3. In order to implement this feature, we also had to implement the packet buffering, which is the ability to store packets in memory. Because if you are running the packet inspection on the traffic at the beginning of the network communication, you don't know, I mean, if it's the first packet, for instance, often you don't know what is the protocol for this packet, the application protocol, because nDPI requires a few packets to detect the protocol in some case. This means that the initial packets in the network communication cannot be forwarded until you detect the protocol, because you don't know if this is DNS and needs to be forwarded on the 4th queue, for instance, or it's something else. This means that we have to store the initial packets in memory until we detect the protocol. So for this reason, we also implemented the per flow packet buffering. So we are able to store in memory up to the memory constraints, or up to the memory size, packets in memory. As soon as we detect the protocol for the flow, we can send the packets which have been buffered to the destination, to the correct egress interface.
So thank you for being here today. As we said, we record this and put it on YouTube and on blog. Thank you very much again. Bye-bye.
Thank you, everyone. Bye-bye.